All right, everybody, this is 7.1. We're talking about solving systems by substitution. All right, so if you remember in the past, you've done this before when you did two linear equations. So here's like an example of this. If you're solving a system of equation by substitution, we are going to substitute one of the equations into the other. So like for the second equation, that's equal to y. So we could take this and we could substitute it into the other equation and we could solve. So that's basically what solving systems of equations is. Looking at it graphically, this is kind of what solving systems is, okay? It's basically if you have two lines, or for this example, we have a parabola and a line. The solutions of a system is where these two equations intersect, okay, where they cross. So when we get into, for this unit, we're going to be having either two solutions, one solution, or no solutions. And those are like the four cases that you could run into. Okay, last year when you did linear equations, there was always one solution, because what kind of makes sense is if you had two lines, they would only be able to cross one time. We also probably talked about how you could have like parallel lines would be no solutions, or you could have infinite solutions if the two equations were the same. Okay, so just a quick reminder on how you did this in the past. Okay, so we substitute that in, we end up getting negative x minus 2 is equal to 2x minus 14. And then we would just solve for x. Again, we'd use inverses. So like, for example, if we want to move this to the other side, we would need to do its opposite. So we would add x, okay? So we'd get negative 2 equals 3x minus 14. And then we could add the opposite of negative 14. We would get positive 14 to both sides. So we'd end up getting 12 is equal to 3x. And then the 3 is being multiplied, so we'd want to do its opposite, is we would divide both sides by 3, and we'd end up getting x equals 4. So again, when we talk about solutions, it's where these two things cross. It's an ordered pair. So we just came up with 4 comma something. If you have the x and you need to find the y, then we can take this and plug it into one of the two equations. And that would give you what y is, because that's what equations do, right? They just relate x's with y's. So if you want to know what y is, then we can just plug that 4 in. So it would be negative x, which x is 4, and then minus 2, so we get negative 6. Again, if we choose to put it into the first equation, then we'd get 2 times 4, and then subtract 14. Well, that's 8 minus 14, which is negative 6. Okay, so it doesn't matter which one you plug it in, because when they intersect, they have to have the exact same value. So our answer here would be 4 comma negative 6. And would have one solution. Okay, so let's talk about how maybe that's a little different when we are doing quadratics. So again, we have two equations, two unknowns, and we're going to solve to find the solutions. Again, we're going to start the same way by plugging this into the other equation. So we'd end up getting negative 3x plus 10 equals x squared minus 11x plus 26. So the thing that's a little different with solving a system with quadratics is, if you remember, when we solve quadratics, everything needs to be on one side. So we would need to add 3x, and then subtract 10 to both sides, so that we could end up getting 0 equals x squared minus 8x plus 16. Okay? And then when we had our, what was that, unit 5, our solving quadratic equations, is there were different ways that you could solve. You could solve by factoring, quadratic formula, completing the square. All of these problems you can solve by factoring. So you are welcome to factor. If you prefer a different way to solve, go for it. Okay, so again, factoring is where we multiply the first and last. So that gives us what we need to multiply to. So what multiplies to 16x squared and could add or subtract to give us negative 8x. Okay, so for this example, it would be negative 4x and negative 4x. That would work. Again, those two things have to have the same two numbers that could multiply and add. Okay, and then if you remember when we talked about if there's no number in front of the x squared, or if a is 1, then we could use the shortcut. Would end up getting 0 equals x minus 4 and x minus 4. Okay, and then from there we would use the zero product property. 0 meaning that the equation is equal to 0, and we have two things that are being multiplied. That means that either x minus 4 has got to be equal to 0, or x minus 4 has got to be equal to 0. Okay? So for this situation, we would end up getting, we could like add 4 and add 4, so we'd get x equals 4, would be one of your solutions. And then this would be the same. So if you end up having two solutions that are exactly the same, obviously you don't need to do it twice. We already know what the other one's going to be. Okay, so we've got our x. Again, we're talking about like a parabola and a line. We want to see the point where they cross. So we need to find the y. So if you have an x and you need a y, then we're going to take that x equals 4 and plug it into one of the easier equation. So we would have negative 3 times x, but here x is 4, plus 10. And this will end up giving us negative 12 plus 10, or negative 2. So now we have our x and our y, that's an ordered pair, 4 comma negative 2. The other solution would be the same, so you don't need to write it twice. So this has one solution, or two solutions that are identical, aka one solution. Alright, so that is the process. Again, we set them equal to each other, right here. We get everything on one side, so it's 0 equals. And then we'll do the puzzle, find the two things that multiply and add. That will end up giving us the two binomials. And from there we will solve for x. So each of them have to be equal to 0. And we'll solve. So we end up getting x equals 4. AKA that's your x-intercept. And then we plug that into one of the two equations above to find y. Just do the one that you think is the easiest. And then from those x and y, that gives us our ordered pair. Alright, so let's try another. Again, we have two equations. Set them equal to each other. That's when they're equal to each other. That's what we want to find, is where they're equal to each other. Okay, get everything on one side, so we'll add 1 to both sides. We'll subtract x from both sides. Again, that is like a 1 negative, or subtract 1x if you wanted to put a 1 in front for the coefficient. So that will give us 0 equals 2x squared plus 12x plus 16. So in the class I asked students, so before we start and do the puzzle, before we factor, what should we always check for first? So again, we should always look, or I guess we should just say divide out any greatest common factors. Okay, so for this example, the greatest common factor is 2. So we'd want to divide both sides by 2. Again, you don't necessarily have to do that all the time, but if you want to use the shortcut, you have to have a equals 1. So here we'll have 0 equals x squared plus 6x plus 8. And then we could use the shortcut. So what multiplies to 8 and adds to give us 6 would give us 2 and 4. So we'd have 0 equals x plus 2 and x plus 4. Okay, so then we're trying to find the solutions, that what x needs to be for each of these binomials to be equal to 0. So here x would have to be negative 2, and on the other side this would have to be x equals negative 4. Okay, for the same reason that we talked about previously. So we've got our x's, we just need to find our y's. So again, look up above and find, this one's probably the easier equation. So we'll do, it's what, x minus 1. So it's y equals x minus 1, which gives us negative 3. And then if we did it for the other equation, or other x, we would get negative 5. So our ordered pair would be negative 2 comma negative 3, and negative 4 comma negative 5. Okay. Let me see. I think D is another one that we need to talk about. We're going to briefly talk about E and F. But just a reminder, this is 2024, just in case I use this video next year. For 2024, you can cross off number 5 and 10 on your homework. If it's not 2024, then don't do that. Okay? Alright, so let's look at D. Again, set it up the same way. There's one more thing that's a little different here, so I want to make sure we talk about that. So 2x minus 1 is equal to 2x squared plus 3x minus 4. Okay, so we'll get everything on one side. So subtract 2x and add 1. So 0 equals 2x squared plus 1x minus 3. Okay, so we kind of talked about in our last problem, we said if there's a greatest common factor, we should divide it out. So does this example have a greatest common factor? No, it doesn't. So here A is 2, and there's no greatest common factor, except for 1, but that doesn't really help us anywhere, okay? So if that's the case, then we are going to have to use the box. We're going to have to factor the longer way, okay? So we still start by doing the puzzle. So what multiplies to negative 6 and needs to add to give us 1x? So I think this would have to be 2 and 3. So a positive 3 and a negative 2. And again, if you multiply those, that turns out good as well. Okay, so again, we cannot, again, don't do this. It's not x plus 3 and x minus 2. Why? Well, if you were to multiply the x's together, it wouldn't give us 2x squared. If we multiplied the 3 and the negative 2, that wouldn't give us the negative 3. And the middle term also wouldn't be the same. So that's the reason why we can't just use that. Okay, so we have to use the box. It's probably been a while since you've done this. Again, the first is your first. The last term is your last. And then the puzzle is the other 2. Sorry, I should probably do the 3x and then the negative 2x. There we go. Okay, so then we just say, well, what's the greatest common factor for each row and column? So we could take out an x, we could take out a negative 1. So again, if the first box is a negative, that's part of the greatest common factor. First column would be 2 and x, and then the last column would be a 3. So now we can write down those two binomials that we had before would be 2x plus 3 and x minus 1. So that was different than what we had above, right? So please make sure you recognize when you have to use the box or not. Okay, so then we write down our two solutions for x. So again, this one's not too bad. Again, you could set it equal to 0, and we could add 1 and add 1. We'd get x equals 1. And then here for the left side, again, we could subtract 3 to both sides. So negative 3 is equal to 2x. And then we'd need to divide both sides by 2. So we get x equals negative 3/2, or if you prefer it as negative 1.5, that's fine. Okay? Although maybe that's kind of hard to see. Maybe we should try this again. Negative 1.5. Alright, so we've got our x's, we just need to find our y's. So we're going to plug it into the easier equation. So that probably we're going to be the y equals 2x minus 1, right? Okay, so let's just plug those in. So we'll have y equals 2 times, and again, if you prefer negative 1.5, or if you prefer the fraction, great. You can use your calculator for both of those, and we should end up getting negative 4. So we've got negative 1.5 comma 4. And then we'll do it for the others. So we'll have y equals 2 times 1. Again, that's coming from here. And then minus 1. And we get 1. So the other solution would be 1 comma 1. Okay, so let's kind of talk about E and F. So E and F, if you were to put these together, you'd end up getting x equals negative x squared minus 4x and then minus 5. The greatest common factor is a negative 1, so we would want to divide, so that's really important. Okay, so if you didn't catch that, make sure you take care of that. Again, that will just change all the signs. But then when we get to the puzzle, it needs to multiply to 5 and adds to 4. And there's nothing that can make that work. At least no, like, no nice numbers, no like integers, whole numbers, okay? So these, if you were to actually use like the quadratic formula, you would end up getting imaginary solutions, okay? I had the idea of maybe talking about this more in class in your homework, but I decided not to kind of go into that as far for this year at least. So for E and F, you don't have to worry about it so much, and the same for like number 5 and 10. Okay, and but yeah, if you were to graph it, it probably would look something like this, and they wouldn't end up crossing each other, so it would have no solutions. Alright, so that's basically it. I'm going to go over C. If you feel like you need a little example, or if there's something on the homework and it looks like this, then you could always come back to this. But if you feel like you're good, then go on and do your homework. Okay, so again, we set them equal to each other. So negative x squared plus 4x is equal to negative x plus 4. Alright, so if you're trying to get everything on one side, again, you can choose which way you want to move them. So if I decide I want to add x, then I could add x here. If I subtract 4, and then you might be like, well, where do I subtract 4 from on the other side? So again, if you are missing a term, you can always put a 0 in there. and we could just subtract 4 from 0. Okay, so we got negative x squared plus 5x minus 4 equals 0. And then again, we have a greatest common factor of a negative 1. So we'd end up getting x squared, minus 5x plus 4 equals 0. And then we'll have to do the puzzle. So what multiplies to 4 that could also add to negative 5? So I think it would be 1 and 4, both negative. Okay, and since we took out that negative, that leading negative, then we can use the shortcut. So we would have x minus 1 and x minus 4 equals 0. And we'll want to find those two solutions for x. So x here would have to be 1, and here x would have to be 4. To find the y's, we just plug it into whichever you think is the easiest. I think it's the y equals negative x plus 4. So we'll do y equals negative 1 plus 4 equals 3. And then we could do y minus 4 plus 4. So we'd get equals 0. So our two solutions would be 1, 3 and 4, 0. All right. If you have any other questions, please let me know. I think that should pretty much cover it. So again, if you need the help over here, these are kind of like the steps. Step 1 is already taken care of for all of these problems. So really it's just 4 steps. So substitute or set them equal to each other. Solve for x by factoring. Substitute that x value into one of the equations to find the y, and then write it as an ordered pair. All right, well, good luck. We'll see you later.